ಗ್ಯಾಂಗ್ ಕಟ್ಕೊಂಬರೋನು ಗ್ಯಾಂಗ್ ಸ್ಟಾರ್, ಅವನೊಬ್ಬನೇ ಬರೋನು.
May I come in?
stand by. The webinar will... Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. I'm Rupa from Department of MCA, RNSIT. I welcome you all for today's webinar on cloud computing and its relevance today. I request our HOD, Dr. N.P. Kavya, to speak few words.
Good afternoon, everybody. It's my privilege to be a part of the team today. Today in this webinar on cloud computing, we have Mr. Ajay Chabi, Senior Technical Staff Member, IBM. Sir, on behalf of RNSIT, on behalf of MCA Department, I extend a hearty welcome to you, sir. And it's a pleasure to have a great personality like Ajay with us today to deliver a talk on this webinar on the topic cloud computing and today's trending requirements. I extend a warm welcome to all participants to this webinar. On to you, Rupa. Kindly introduce our speaker of the day to the participants. Welcome, sir.
Okay, ma'am. Thank you. Let me introduce today's speaker, Mr. Ajay Chubby, Senior Technical Staff Member, Chief Architect, Application Development Capabilities for IBM Cloud. He is much sought after expert in mobile middleware on public cloud. Very recently, he has successfully led the architecture and development of IBM Mobile Foundation on IBM Cloud. He has also delivered mobile middleware platform integration with Xamarin and unifying the IBM roadmap for Microsoft Mobile Technologies. He also regularly speaks at conferences, delivers webinars, and authors articles, blogs, and author product sample code, etc. Without taking much time, now I request Mr. Ajay Chubby to take over.
Can you hear me now?
Good afternoon, sir.
Good afternoon,
Yeah,
sir.
hi. Good afternoon. Can you hear me all right?
Yes, sir. Yes.
Okay, yeah.
Yes, sir.
Thank you very much for the kind words, Kava ma'am and Rupa ma'am. It's really an honor to speak on behalf of your department. So without much ado, let's get started. So if you can confirm to me if you can see my slide deck.
Yes, sir. We can see, sir.
Okay. Good afternoon, everybody. Today I will talk a little bit about cloud computing and its relevance today at a little higher level, because cloud computing involves a lot of things, and we cannot cover everything in 1 hour in depth. But I'm hoping I can give you a broad idea on a breadth level on what it is, why it is needed, and what are the technological aspects of it. And maybe we can leave some time for Q&A at the end. So can we do Q&A at the end? Is that facility available? So people can send chat.
Sir, it's only visible to organizers, sir. I'll read out the questions.
Perfect. So let's do that. Maybe just please send them out, and the organizers can read them out, and I'll try to answer the best I can.
Sure.
So a little quote that I found while reading a book recently. Just because you can't imagine doesn't mean it doesn't exist. The character of Shiva says in The Secret of Kanaga. So with cloud computing technologies, it's up to you to imagine what you can do with it. So don't get stuck in the question of what I can do with the cloud, what I can do with this piece of technology, what I can do with cloud technology. You have to imagine something, a problem, a solution, and then cloud becomes a tool in your hands to solve that problem. So today, the way applications are built, you can still see the slide deck? If you're not seeing the slide deck, just let me know. So the way the applications are built today, maybe you're building on the laptop, some piece of code that is a server-side code, or maybe you're building a mobile app. Maybe you are building a machine learning AI ML application. or maybe you are building a IoT application. There are various technologies available, and so cloud is two pieces. One is the cloud platforms that exist in the market today, which are AWS, IBM Cloud, Google Cloud, and Microsoft Azure are the leaders in this segment. And there also is the cloud computing technology aspect, which is called the cloud native computing. We'll touch upon cloud native computing maybe a little more. So no matter what kind of app you are developing today, you can leverage the cloud to make your life easy. You can leverage the cloud to develop and deliver that app really quick by using all these technologies. If you need a database, a NoSQL database like CouchDB, which is Cloudant, or a SQL database like Postgres, or you're writing a piece of code in Node.js, right? All of these, as a computer application and computer science students, you should definitely know what goes into installing and configuring a piece of software. But while developing applications, you are better off spending less time on installing and configuring applications than building your own applications. Installing and configuring software like a database server, and your time is more productively better spent on building the actual application you're building to solve a particular problem. Particularly on AI ML, you can do things like Jupyter notebooks, etc. on your laptop, but when you're building a real life model, it needs huge computing power, and that is best served by cloud. So in a sense, let's try to see what is cloud, right, at a very high level. So if somebody asks you what is cloud, you can answer it is somebody else's machine, right? Essentially, that's the simplest answer. Cloud is somebody else's machine. So on the left hand side, which is what you probably do your exercises on, right, is right from networking all the way up to your application, is on your laptops, is on your machines. And that is how till some time ago even the industry operated. The banks today also operate pretty much like this. It's changing, but today they operate like this because of they have a lot of rules and regulations and government governance aspects. So they have to keep them all in their own data center. So when a particular bank runs this software, they may have the leftmost, or they may have the second from the left, right? The number 2, which is infrastructure as a service in a private form. So your networking, storage servers, and virtualization. So virtualization is a VM, right? Is managed by a vendor in cloud, like IBM Cloud or AWS. And then you bring in, so they give you VMs on the cloud, and then you, the developer, then brings in, installs the OS on it, installs any middleware that you want on it, install the runtime on it. So middleware is like Kafka, right? An event stream, a messaging software, and then a database server like MySQL. That all becomes middleware. And then the runtime, which is a Node.js server or a Java VM, right, or Tomcat. And then you bring your data, which is your configuration, XML, JSON, etc., and then the actual application that you build on top, that you do, which is the client manages part. Then moving a little bit more over to the right, which is called platform as a service, right? In the second column, infrastructure as a service, you are quote unquote outsourcing up to the virtualization layer. You are the one bringing the OS. But when you're using a platform as a service, you are even bringing in, you're even sort of outsourcing the OS middleware and runtime as well, which means You are not installing the OS, you are not installing the middleware like your database servers and whatnot. You are also not installing your Tomcat server or your Node.js server. Right? All that is brought in with the click of a button in various form factors, which we will see. There are two very popular paradigms here with rather open source platforms. One is called Cloud Foundry, and the second one is called Kubernetes. There are two styles of writing cloud native applications. So you need, as somebody who wants to understand and leverage the cloud, you need to start paying attention to the rightmost two columns. So what is the rightmost? Software as a service. Software as a service is you use AI and ML, for example, right? Like IBM Watson, as an API, as a REST API, right? You don't care where it is running, how it is running, who installed it, what version it is. You just use it as a service. The entire software application is used as a service, right? So that is so. For example, Gmail, right? Gmail is SaaS. If you connect Gmail to your mail app on your phone, your Gmail becomes software as a service. Your phone mail app is connecting using APIs to Gmail, and it's bringing the mails. You're reading it, editing, replying, deleting, and then the API goes back to the Gmail server, and your work is done. You're not worried about what version it is and how much capacity it is, etc. So your code that you are writing will be on a platform as a service, and you will be leveraging software as a service in the cloud paradigm of development. So a lot of things you should be using software as a service, and then you should be writing your software on platform as a service. So why all this, right? Why would anybody want to do this? So which is, the more left you go, the more more customization you have to do. It's higher cost. Upgrade costs are very high. Imagine changing your laptop every 2 years, right? Because it's getting slower and slower. It's not getting slower. Faster machines are coming out. But if you go to the right-hand side, rightmost, you are sort of renting somebody else's machine and compute. And they are responsible for bringing in the latest hardware, upgrading to the latest storage, bringing in petabytes and petabytes of storage that you can use. So standardization using technologies like Kubernetes and Cloud Foundry. I will go into Kubernetes a little bit. And then that makes lower cost, and then faster time to value. Faster time to value is important in today's world. Is if you have an idea in your mind and you want to build a app for, like the Arogya Setu app for tracking COVID infections, is your time better spent installing the operating system and installing the database and taking the backups of the database? Or would you use database as a service so that the backups are taken care by someone, the security is taken care by someone, you're just paying them a rent, right? As a monthly rent. And hopefully, right, one day COVID should go away. Once COVID goes away, let's say the Arogya Setu app may not be needed anymore. So they didn't have to buy hardware, which is a permanent investment. They'll just keep on renting the software as a service till the time it is needed. 3 years from now, they'll just say we don't need it, and they'll stop paying the rent on it. Right? Left is owning your house, right is renting your house. The advantage of renting your house is you can always move to sometimes a bungalow and sometimes a flat, sometimes a bigger flat. With the left-hand side is owning a house, is you're stuck for a longer time with whatever you've bought. And changing that involves a lot more effort. So that is, in a sense, what cloud is and how the various forms of cloud. So people use infrastructure as a service, platform as a service, and software as a service, depending on their usage in industry. So cloud native computing concepts. Can you confirm if you see my slide? Because I got a message saying sharing is paused.
No, sir, we can see, sir.
Okay, cloud native compute. Yeah.
Yeah,
Okay.
cloud native computing concepts.
Okay. So let's talk about cloud native computing concepts, right? What is cloud native computing mean? So previously, even today to a large extent, you write a piece of software, and then let's say you write a server side piece. You must be familiar with the 3-tier approach, right? Your data, business logic, and the UI. So you're writing the business logic, which essentially the UI talks to it using an API. And then you write 10 APIs on the same server. So that's a monolithic server, right? So everything is running in the same process space. With that, what happens is if one API is used a lot, the other APIs start becoming slower, right? Because the computing capacity available to your VM, your JVM, or node server is only limited by what the CPU can provide. So it looks like 10 of us traveling in a bus. If the driver decides to go slow, all the 10 of us are slow. If one of them has to get down because they have feeling a little giddy, then everybody stops, right? And that's not an ideal model in computing. So the first concept that you will hear in cloud native computing is microservices. So microservices is like taking all those 9 people inside the bus. So 10th is the driver, right? So we chuck him out, take the 9 passengers, give each of them a motorcycle or their own vehicles. So each of them can run at their own speed. Each person may have a different activity they need to achieve before getting to the final place. Maybe somebody has to carry a heavy load because they have to do a delivery. Maybe somebody has to travel more kilometers because they have to go in all different directions. So each of them can be given a motorcycle or a scooter that is suited for that purpose. And then eventually they all can reach the destination. So that's sort of the analogy for what microservices are. So instead of you having 9 APIs served by the same server running in a process space, you now have 9 servers. Okay. And I'll talk about what I mean by servers. So you have 9 servers, each of them supporting one API. So with that, what are the advantages? Why do we do this? Like I said, if one API is heavily used, then what happens is just that one API, that one scooter slows down. If the petrol in one scooter is over, right, the 8 others can still continue to move. Version upgrades. Let's say you want to make code changes to just one API, right? Let's say you're building Gmail yourself. And let's say you want to make changes to the get contacts, your email contacts that you have, API. Then you can patch only that one server, right? Just this one scooter, just that one API, the server that's running that API. And the others can continue to run unaffected without any downtime, right? You don't have to bring them down. In the monolithic case, if you have to fix one API and you need to apply the new software which contains the modified API, you have to bring the entire server down for 5 minutes, 10 minutes if you're lucky. If you're unlucky, something happens and there is a bug in production, you're down for more than what you were hoping for, right? Hopefully not several hours. So with microservices, you can patch only that one server with the right versions of the API that you want, and then the others can continue. If that upgrade patch is faulty and if it fails, then you can just revert back that one microservice or apply a patch to that one microservice. Your entire site is now running at 95% efficiency, but it's not zero, right? That's important. So how is this used in real life? So if you go to Amazon website, so you see various pieces, right? If you're logged into the website, you will see your orders, you will see what's new, and then you will see, based on your search history, you may like to buy these new items, right? So if you have recently bought a phone, they will give you a recommendation. Maybe you may want to buy a phone case. Maybe you may want to buy some nice earphones. Maybe you may want to buy the tempered glass on top. So each of those are microservices. So let's say there's something wrong with the recommendations of what products you should buy. It doesn't bring down the whole site, right? The rest of the areas on the web page, which is backed by individual APIs, continues to work. Maybe just that one piece doesn't work, which is the recommendation engine, and that's okay. They can either collapse the section, or they can just show some non-specified random recommendations. Hey, this is COVID times. You want to buy a mask? You want to buy a sanitizer? Because that engine which keeps track of what you've bought and what you would like to buy if you bought a phone is down, or it has a bug, or is down for maintenance, or they're upgrading it. And if they want to update it with a newer version which does AI and ML, then you can also just patch that one server, the recommendation engine API. So that is the beauty of the microservices paradigm. If you go online and read about the microservices, you'll find a lot of information on the 12-factor microservices, etc. We'll not go into that because that's all available out there, right? The Agile Manifesto, the 12-factor microservices, etc. You can go read that up. But fundamentally, to understand why microservices is very important, then you will be able to make the right decisions. Everything in real life is not microservices, right? We still have some monolithic servers, and they're okay. You eventually gradually move them over to microservices. So that's about one major concept in cloud native computing. So we saw infrastructure as a service, platform as a service, software as a service. Then next we saw how to build applications on the cloud. So these paradigms, the microservices paradigm, is not only applicable to those clouds that I mentioned earlier, right? Which are the IBM cloud and the Google cloud and the AWS cloud. You can run all these on your laptop, right? Using Docker Desktop. Or you can use some other software. There are a lot of softwares available. Or even in real life, there are things called private cloud, where if it is super sensitive data like a bank, they may set up a private cloud right in their data center, and you can leverage all these new modern capabilities, even while running on your laptop or while you're in your data center or on your machine. So these are architectural concepts that can be applied. So you don't have to use cloud native concepts only when you're running on a cloud. You can run Kubernetes on your laptop or Docker on your laptop. We'll look at Docker and Kubernetes in a second. So how do you run these microservices? So on the left-hand side is traditional, right? We looked at what traditional is, where you have hardware, OS, and then you have apps running on it. For example, your laptop. The center is the virtualized, where I hope you guys are aware of virtual machines. This Oracle VirtualBox is a free software that you can use to run VMs. Linux by native, Linux has native support for virtualization. Or there are commercial products like VMware, right, which do virtualization, where hardware, operating system, and the hypervisor, which is the layer which provides virtualization, is common. And then on top of it is a virtual machine. It's not a real machine. All this is running on one machine, but you can, to the app that you are running, it seems like it's running in its own machine, right? It still is constrained because you need to get the dependencies and the operating system yourself. The hypervisor just provides virtualization abilities, but you have to bring in the This is not a appropriate platform for doing microservices. So people can say that we are doing microservices using virtualization, but that's not true microservices. You're still, lugging a lot of weight of the VM. Finally, on the right-hand side, which is the new paradigm which has come about, which is called containerization, where your hardware, operating system, and the container runtime is common. And then there is the container on top, which contains base of the operating system, because ultimately you need an operating system. So there you have the concept of a host operating system and a guest operating system. And all you need to do is write your app. Maybe it is in Node.js, maybe it is in Java, maybe it is in Go, and just bring in whatever libraries you are using, React, Angular, whatever, and containerize that part. So you as an app developer are now worrying only about your app and the app dependencies, not about the dependencies of the dependency, which is the operating system. Oh, this won't run on Linux version so-and-so, that won't run on Windows version so-and-so. You don't get into those issues. And with that, the container becomes very lightweight. And it becomes super lightweight, and you can have thousands of them running, even on a Raspberry Pi, right? You can run all this on an RPi, let alone your laptop. And you could have hundreds in an RPi. Actually, they've scaled up to 3,000 containers the last time I checked on a small RPi. So since each of, like we said, each of them is a scooter, each of them is not your tempo traveler, right? They're very lightweight, small. You can have multiple of those. Now your problem, okay, now you understood containerization, you like containerization, you want to containerize your app. Once you start building these, earlier you thought you'll build one server, now you're building 9 servers. How are you going to orchestrate all of this? How are you going to make sure they all are deployed, all are up, all are running, right? That starts becoming the problem. So each of these apps, containers, you containerize in a standard, which is, Docker is one of those standards. Containers, there are etcd and Docker both. So let's say Docker is very popular. So you make them into Docker images. So what you just did is you decoupled the app from the machine part. You don't care what the machine is running. You just said, this is my dependency, this is my app, go run it, right? So next is, now I still have these 9 things that I need to manage. Comes Kubernetes. So Docker, Kubernetes, these are all open source softwares, open source platforms. So Kubernetes is founded by Google, IBM, Microsoft, Amazon, Lyft. A lot of companies have contributed to support the Kubernetes platform. It's all on open source. You can just go and use it, and to add weight to your resume, not just Kubernetes, you should go contribute to open source software. go fix bugs in the open source software that you use, right? Having in your resume saying you contributed to Apache so-and-so is a fantastic thing for a prospective employer. So you should use open source. You should also contribute to open source. Maybe it's about just fixing the documentation or fixing a bug, whatever. So you should do that. So okay, it's a Docker for containerization, Kubernetes for orchestration. What Kubernetes does is it decouples those apps from the infrastructure. So in real life, you need what is called disaster recovery, right? Where if one machine, disaster recovery and high availability, right? HA and DR. So if one machine fails, one physical machine fails, the CPU burns up, you don't want your apps to stop, because now you don't have one, you have 9 apps. All of them will stop. So Kubernetes allows you to bring in the concept of multiple machines to the what they call as the cluster, right? Kubernetes cluster. I mean, with the COVID times, you have probably heard the word cluster quite more than you really want to. So Kubernetes sets up a cluster. You can add machines to it, and then it creates what are called nodes. We will not go into the depth of Kubernetes. You can go to kubernetes.io and read it up. It's a very beautiful documentation, very entry-level documentation up to advanced level. It's very easy to learn. You can set it up free on your laptop and experiment with it. So you decouple from the infrastructure. So you may decide to bring in a Windows machine to the cluster, a Linux machine to the cluster, doesn't matter. So long as it has the right environment, it can participate. It can run these little scooters that we had, right? Little APIs, the containers, on anyone. So it sort of creates a farm of container nodes. So that makes your app management easy. There are a lot of things. I will not go too much into what all Kubernetes does, but it allows you to find out how many APIs in total are running, right? At the end of the day, if you're writing 9 servers or 9 APIs, you want a dashboard to see how all my 9 APIs are doing. Am I getting any failures on it? Is there what is the performance numbers? What is the latency? What is the speed? All those things. And that is what Kubernetes allows you to do. There are a lot of Kubernetes extensions as well on top of it, like Istio, like Razi. We will not go into the depth of all of these, but once you start getting familiar with Kubernetes, you will start learning the ecosystem. And those are what help you in running your applications much better. So you must have heard of the concept of DevOps. So DevOps is development and operations. So my team, for example, we don't have people who do build and release and maintenance. My entire team, so we have 20 people running push notification service. We code, we test, we deploy, we manage, we monitor, we take calls from customers. We are responsible for keeping that software up and running in 6 locations in the world, because we have 6 regions that we are supporting today. So all the developers are also responsible for the operations of it. And this is where Kubernetes was born out of, is you want to have a reliable site, right? The Amazon example I gave, even if the recommendation engine is down, you don't want the whole site to come down. That's not really nice. So you use microservices for that. You use a platform like Kubernetes for that, so that your all the software developers know how their software is running. They are the ones responsible for managing, maintaining, and as we said, we are not decoupled from the machine and the infrastructure both. So your software can run in a test environment, and so long as it is running the same version of Docker and Kubernetes in your production, it is guaranteed to run there. So this concept is called portability. So you can take these 9 microservices from here, put up what is called a DevOps pipeline, which is there's some build and deploy tools like Chef and Puppet and Jenkins and Tecton, and deploy them all on production, and they will run exactly like they were running in the development environment, because there is no difference. Right, you've abstracted all of that, the bottom layer out, all the dependencies down. Most of the times failures happen because dependencies don't match. You're using version 3.2.1 of something in your development and test. In production, it happens to have 2 point something. So obviously your software will start failing. So that is what happens. So in real life, even though microservices as a theory is fantastic, there are when you start putting that in real life, you start applying microservices in real life, this is the problems you start getting into. And that's why you need something like Kubernetes. So when you talk of cloud computing, you will be doing microservices, you'll be doing Docker, you'll be doing Kubernetes. And why it is relevant? Because you want to build software and websites which are up all the time. You want minimum failure. And you don't want to spend too much time, right? If one of you has a startup idea, right? Or if you're in a hackathon, like the recent IBM Call for Code hackathon, hope you guys participated in it. It's time bound, just like a startup environment, right? You got to put something out to your customers within a fixed time. You don't have like 3 years to do it. And you want to do it fast. Cloud is the way to go. And that's today's world, because if you are not putting the software out faster than the other person, then you lose the first the first comer advantage in the market. So you have to leverage cloud. You have to leverage cloud computing technologies so you can build reliable software that is up all the time and fast, without having to worry about low value ideas or low value tasks, right? Like installing MySQL. So unless you are a person on the MySQL development team, or you are the one building, you're employed by IBM Cloud and you are the one building the MySQL server itself, now you shouldn't be worried about installing MySQL. You should just go rent an instance of MySQL. So ultimately, once we've bought into all of this, right, and we said, okay, I'm going to start doing microservices, and this is what you land up in real life. So I hope you guys are Star Wars fan. In Star Wars, there is the Death Star, right, that is being built. So this is on the left is a dependency map of Twitter.com. So each of the lines show, each of those, the sun-like spokes that you see, the rays, is a microservice name. It's not relevant what it is. And each of the lines show the dependencies. Which microservice is dependent on which microservice. So this microservice here is dependent on 5 other microservices. That microservice there is dependent on 25 other microservices. So you start building a dependency graph, and you land up with a big giant Death Star like this. This is a much older picture, and entire Twitter.com was 500 plus microservices. So that's how you run a very high performance, you build a very high performance, scalable website or a scalable software by using cloud native computing technologies. So a few things about the software and the open source that is used in the cloud native world. So these are the list of services I have from the IBM Cloud. So Cloud Foundry has these concepts called build packs. So build packs are essentially, the little piece below, so that you just write this software, which is a Node.js program that you want to run, and say, I want to use the Node.js build pack, right? Build pack version so and so. That's it. You don't even install Node.js. You just say, I want that version of Node.js. Same with Java, right? Go. There are hundreds and thousands of build packs that are available in open source. So Cloud Foundry is one technology. There are custom software like WebSphere. WebSphere is a J2EE application server. I don't know if you guys still study J2EE, Java to Enterprise Edition, but you can get commercial software which also is containerized. You get open source that is containerized, commercial software that is containerized. So the number 2 and number 3, hosted WebSphere, Mobile Foundation are commercial softwares. The Mobile Foundation is the software which is used by most of the banks in India. Most of the mobile apps of the banks in India run Mobile Foundation as the mobile gateway, which is a part of the team that I belong to. And then push notification is a SaaS. It's a software as a service. So the notification that you get on a mobile app whenever your order is dispatched are called push notifications, and that needs a bunch of software to be maintained. And as somebody who set up some new shopping website, you don't want to maintain push notifications. You are better off using a SaaS, a software from a cloud vendor. There are a lot of security services available. So for example, Google authentication, right? Whenever you log into a website, sometimes you see login using Google or Facebook. So that's a security SaaS. That's a security software as a service, whereby you're just embedding a little widget or component inside your page, and somebody else takes care of username, password, authentication, lost password, password recovery, lockout. There's the whole life cycle around just username, passwords. All that is taken care by somebody else. And I was talking about DevOps toolkit, but when you start developing software in real life, you need to track issues, right? So Git issues, for example. If you use GitHub, you would know Git issues. You may want a hosted Git, not just github.com. The same software is available as open source, and you can deploy it as a private source repository. If you have sensitive software, you don't want to put it in public, right? You may want to host it privately. And then the delivery pipelines, which is the DevOps pipelines that I was earlier talking about, like Jenkins, Chef, Puppet, right? Tecton, all of those. And then once your software is written, you need to monitor how it is doing, the apps. So there are open sources like sysdig and logDNA, which allow you to keep the logs, so they're not just in files. Permanent archival of logs and other events like failures, server crashed, etc. And then ultimately you also will start, as you start building complicated applications, you will start needing internet services like domain name servers, global load balancers. So global load balancer is this is how real life applications work. Is you don't want, if the internet main cable to India gets cut, the internet is actually not in the air, right? It's physical cables running under the ocean. So you should go look up. It's very fascinating. There's fiber optic cables that are laid across the oceans. It's the deep sea cables. If one of them gets cut, then you don't want, or if Airtel is a provider. Let's say Airtel suffers a loss. you don't want your application to go down because some third party, like the cable provider, the deep sea cable provider, or Airtel, their network went down. So you will host your software in India as well as in Japan and in Europe, and you will use something called as a global load balancer. So anybody who goes to mysite.com can be routed to any of these three. So they don't know the difference. Your users never get to know the difference where it is served from. So if one site goes down, the other two sites are still working. So when you start building real world scale software, you start needing all these things. So you may be a cloud user, you may be the one building the cloud, right? So you need all these tools, and then content delivery network, etc. Right? So if you go on Instagram and you look at pictures, how come they load so fast no matter where you are? Right? Obviously they're stored somewhere, isn't it? But it's not that the Instagram picture coming to your mobile phone or your web page, your browser rather, is coming all the way from the servers in the US. So there is a content delivery network that private companies like Akamai provide, where this content is distributed all over. And then it says, oh, I have it. And then Akamai may have a storage facility in Chennai, right? Or in Mumbai. These are the two hubs, network hubs in India. And that image gets downloaded from there, not from California. So this is some of the landscape of cloud software tooling technologies, private software, open source software, etc. And now I think we should pause for questions. We have about 10 minutes left. Are there any questions?
Yes, participants can ask questions unmuting themselves.
Sir, good afternoon. I have a question related to
Yes,
Dockers.
please.
Dockers are limited to only containers that is running on the applications. What is the major advantage we can find, sir?
So it's actually sort of the other way around, right? Let's look at this right-hand side.
Yes.
You can see the screen, right?
Yeah.
What is containerization is what I'm showing. So this entire software, unfortunately, it's a different shade of blue, so you can't really see. So the container runtime is what Docker provides you. So the application is running in a container on Docker. So it's sort of the other way around to look at it. The application is not using Docker. Application is running inside Docker. It's like an app running inside an OS process space. So that was
Muted.
okay. So did that answer your question?
Unmuted.
Yes, sir. And I have a small continuation question. In the Docker Hub,
Yeah.
can we also contribute some of the Dockers? In the Docker,
Images.
Yeah, images, Docker images. Can I also write?
Yes, you can. Right. So okay, good. Excellent point you bring up. So people familiar with containers and Dockers, right? So there is a global repository of containers called Docker Hub. Thank you for bringing that up, right? That's another very important concept. Where if you want a Linux operating system with Node.js server install and MySQL installed inside your container image is the sort of the definition of your runtime, then you don't have to build it yourself. You can just go to Docker Hub and search it, and you'll find that somebody has already contributed to it. And so that's your bin library, right? Which is the Node.js and MySQL. You just build the app and say, I want to use this image from Docker Hub. That's all. So you can just use that image and the entire stack is ready for you. That's the beauty of containers. Or if you have your own special sauce of software that you didn't find on Docker Hub, you can go contribute it back to Docker Hub. Right? You can contribute it back to Docker Hub saying, hey, I didn't find this, here you go, this is my contribution back. So Docker Hub is an important repository of images.
Thank you, sir. Yeah, it was wonderful.
Yeah. Any other questions?
You can unmute yourself and ask questions. Participants, you can unmute yourself and you can ask questions.
So I have a question.
Yes, please.
Sir, what about the security features related to the cloud, sir? How is it more secure, cloud features?
So sure. Good question. I'm just trying to see how I can share my browser. Just 1 second. Tell me if you can see my no? Let's see, hold on, I'm having a little I'm going to unshare and then let's see, give me 1 second, I'm just trying to okay, found it. Okay, tell me if you can see my browser.
Yes, we can see.
Okay, so let me so I'm logging into IBM Cloud, right? When the sharing is on, a little longer time. And if you see, I seem to have used 30,000 rupees worth of software so far, right? I don't plan on paying that because this is my internal IBM account. But that's what somebody else, another company is using that, will see. So these are the softwares or the SaaS or the PaaS that I'm using. These are the instances. So I have a cloud and database. I have a service called App ID. I have a service called Mobile Foundation, Activity Tracker with Log DNA, right? And then Key Protect, etc. So these are the softwares that are running, and I am consuming those. So this is how essentially cloud works. So let's go to see what all is available for me to use. So I'll come to the security question in 1 second. So I can go to services and see there are so many services available. So one of the services that you see, one of the category of services is called security. So under security, there are a bunch of security services that are available for you to use, which you don't have to sit and set up, but is available for you to use. For example, Security Manager. If you have, Certificate Manager. If you have certificates that you need to manage, the most secure way of that is to actually put it in a lock and key. So that's what a certificate manager is. So you can open it up. It's like a wallet. of certificates, right? That is for enterprises to use, and then you can use hyperprotect crypto services. So IBM Cloud provides you with cryptography services where typically encryption decryption is very hard compute intensive. But if you use this service, you can. So I just clicked on it. What I wanted to show you was it supports using FIPS 120 level 2 4 certified hardware. So IBM says this is what we guarantee you, and that's how you know that what level of security is your key, that what your certificate we were talking about is protected with, right? So you can even keep your own key, the encryption key. You can keep it with yourself. So even IBM cannot decrypt your data. And this facility is available for databases, for runtimes. We are certified using a whole bunch of security certifications like ISO and HIPAA and FIPS and a whole lot. So that's how you can use security services to add security to your application, and your data and application is running in a secure environment. So that is how the security is addressed in a cloud, and not just IBM Cloud. I have access to IBM Cloud, so I'm showing you IBM Cloud. Pretty much all the clouds have similar capabilities, and they run on secure software. I hope that answered the question.
Yeah, thank you, sir.
Yeah. Any other questions?
So there is a question from Pat Spencer.
Yes.
Do IBM Cloud provide free trials?
Yes, IBM Cloud does provide free trials. It is 30-day trial, I believe. You can create an account using your personal email ID, and it gives you free trial. There's some software that is available. Not everything is available under free. If you see have light and free, right? So there is a light plan and a free plan. So two different plans. Light plans are available for anyone. Free plans are available for verified users. So there is a step in this which is you can just go fill in the form, create an account. You're eligible for light. You put in your credit card, you're eligible for free. The moment you put your credit card, it does not mean your card is going to get charged. If you continue to use light and free tiers, you will not get charged. The credit card is used just to sort of identify you, because we've seen people use Kubernetes clusters and databases to run malicious software. So we want to be able to identify who you are, and that's why the credit card step is added. So I hope that answers your question.
Thank you, sir.
Yeah. So,
any other questions from participants?
If any other questions? In the meanwhile, so if you want to get a chatbot, all you have to do is go click on Watson Assistant and say create. That's it. Now you have a chatbot interface ready. You don't have to sit and install any software. Are there any other questions?
Yes, so I think we can end the session. So, dear
Hi, sir.
participant, okay. Yes.
Hi, sir.
And
Hi, sir. I'm Chandrasekhar from RNSIT MCA.
Yep, go ahead.
What is the right path to get ourselves involved in Docker projects?
So, first thing is you should do is sign up yourself for the Docker meetup. So there's, I hope you guys are aware of meetups.
Yes.
So you can go to meetup.com and search for the Bangalore chapter of Docker, the Docker meetup, the Docker chapter, and there you'll meet a lot of people, and there you'll get a lot of guidance on how you can contribute back to Docker, or you can get a Docker project, or you can just try to build, a sample Docker app yourself, because you can install Docker on your laptop, right? It's called Docker Desktop. You can install Docker Desktop on your laptop, and you can run Docker yourself and build something. Right, so either you can contribute to Docker itself, or you can build Docker apps yourself. One of the two is possible.
Thank you, sir.
Yeah. So if we don't have any other questions, hope all you guys are staying safe in these times. Try to use this time as much as you can to learn all these open source technologies. They're available, they're open, they're free, and a lot of trials are available. And hope you have a wonderful future ahead in the cloud computing industry. Back to you, ma'am.
thank you, sir. Thank you, sir. Participants, feedback link and certificates are sent to your registered email ID. Now it's time for vote of thanks. On behalf of MCA Department, RNSIT, I take this opportunity to thank Mr. Ajay Chappi for taking time out of his busy schedule and speaking at webinar on cloud computing and its relevance. It was a thoroughly enlightening and informative session for participants, sir. I hope we get more such opportunities in future to listen to you, sir.
Yes, indeed. I'll be very happy.
Thank you, sir. I would like to thank our HOD, Dr. N.P. Kapia, for her support and guidance in conducting this webinar. I would also like to thank Dr. Ramasatish KV for helping us to go live on YouTube, and our student Chandrasekhar for designing the wonderful brochure for the webinar. And last but not least, all the participants for being such wonderful listeners. Thank you all. So shall we end?
Thank you.
Thank you, sir.
ಸಕ್ಸಸ್ ಆಯಿತು ಫೈನಲಿ ನಿಮಗೆ ಅನ್ಕೊಂಡಿದ್ದೆಲ್ಲ